Hello, my name is Mustafa, and this work is done by myself and Mark Smucker from the University of Waterloo. We're all familiar with what a typical search process is. So once a user submits a query to a search engine and they're presented with the search result, the user interaction with the SERP is influenced by the content of the SERP and how the user perceives it. However, recent work proposed that the likelihood of a user continuing to examine search result may be modulated by not just the presence or absence of relevant result, but by the nature of the non-relevant result as well. For example, let's imagine a user who's interested in knowing the age of Axl Rose, the celebrity singer. In this search task, a relevant search result should contain information about the singer's age. For example, the first result on the left, which is the singer's Wikipedia page, would be relevant. The other two, we consider them to be non-relevant to the search task. It's reasonable to say that the search result regarding the singer's online photo album, which is in the middle here, is a subtopic related to Axl Rose, but it's actually not relevant to the search task, which is finding the singer's age. The last search result talks about AXL, the gene. This search result has nothing in common with the singer Axl Rose and is way off, and we consider it to be egregiously non-relevant. In this work, our goal is to investigate how the nature of non-relevant material affects users' willingness to further explore a ranked list of search results and their decision to abandon their queries. In other words, our attention is to understand user behavior when the SERP has no relevant documents, and how far in the SERP users are willing to examine. To do our investigation, we first define a spectrum of possible SERPs. Please note that this spectrum is not meant to cover all possible SERPs out there. It's just meant to give us an idea of the different ways the SERP can be designed. The left side of the spectrum indicates lower quality SERPs, whereas the right side indicates higher quality SERPs. Let's look at each SERP for the same search task, which is finding the singer's age. In the first SERP, all of the results are coherent with each other, and they're all related to a single egregious topic. This SERP represents a search engine that completely fails to understand the user information need and focuses on returning result on a single egregious topic. Here, the SERP contains multiple egregious topics that are not related to the search topic nor to each other. We consider this SERP to be better than the previous one because it attempts to diversify result. However, it just wasn't successful in returning anything related to the user search task. This SERP is similar to the previous one, except it contains result related to a singer in some sense. Here, in the second example, it has information about the Axl Rose news. However, this result is not relevant to the search task, which is finding the age of the singer, so it doesn't really help the user find the correct information. In this SERP, all of the results are coherent with each other. All of them are news related to the singer. They all mention the right topic, except none of them actually help the user find the correct information. This scenario can represent a search engine that understood the searcher's topic but did not return anything relevant to the search task. This is similar to the previous SERP, but all of the results are diversified. For example, we have social media photos and news of the singer. This SERP covers multiple subtopics of Axl Rose, but none of them help the user find the correct information they're looking for. In the last two SERPs, they actually contain search result with the correct information. If the user clicks on the relevant document, they would actually get the correct answer to the search task. In this experiment, we're interested in comparing these three types of SERPs, which we call A, C, and E. These SERPs contain only non-relevant results, but with various degrees. We conducted a user study to study users' behavior when the SERPs are in each of these three conditions. Participants used mobile search interface to answer some task questions. This study was conducted remotely via Zoom. Each participant completed 12 search tasks. Each search task consisted of a question. In 6 of the search tasks, we showed participants manipulate a SERP that follow each of the three conditions, A, E, and C. In the 6th search task, the other search task, we showed participants search results fetched directly from the Bing API. This is how the interface looks like. The search task question is shown at the top of the page. A search box is provided to allow users to enter their queries. Once a user submits their query, 3 results are shown to the user by default. To view more results, users would need to click on the More Result button at the bottom of the page. When a user requests more results, an additional 3 results are added for up to 15 results. We had 2 main hypotheses. The first one is that when search results seem to be moving away from leading the searcher to the correct information, the searcher will be less inclined to view more items within the search page. Our second hypothesis is that as the overall representation of the search results seem to be moving away from leading the searcher to the correct information, the searcher will abandon the search results the fastest. We recruited 26 participants, but we only used 20 for the analysis. Our participants included university students as well as few professionals. Results. Our first result is related to our first hypothesis. The left figure shows the fraction of clicking the More Result button under each condition. The count indicates the number of times a user requested to view more results. The number in the small box shows the fraction of clicking the button at least once in each condition. And the right figure is based on the left figure data. We calculate the probability of examination at different ranks. The ranks are grouped into 3 elements because we show 3 results in the SERP each time a user clicks on the More Result button. What we see here is that among our 3 conditions, users' lowest fraction of viewing more result is when they are presented with search result coherent on a single egregious topic, which is our condition A. As the SERP improves, they have a higher fraction of requesting more results. In the 2 conditions A and E, where the SERPs are in the extreme opposite side of the spectrum, the difference is statistically significant. Our second result is related to our second hypothesis. The plot shows how long before a user decides that the search results are not worthy of examining or embedding into the SERP. We did not find a statistical significance here, but the figure follows what we originally hypothesized. In summary, we found that users are likely to examine more results when they're presented with diversified search results on multiple subtopics. As the result in the SERP contains more off-topic and egregiously non-relevant results, users are less likely to examine more than the first 3 results in the search page. One implication is to extend graded relevance to the non-relevant document as well. For example, the non-relevant class would have non-relevant as well as egregiously non-relevant. Thank you for listening, and please read the paper for more results and discussion.